Now you are welcome to this class, and today we want to talk about the Kirchhoff laws. Now these Kirchhoff laws are very important in circuit analysis. Kirchhoff proposed two different laws. We have something we call the Kirchhoff current law, and it's shortened as KCL. Then we have the Kirchhoff voltage law, which is also shortened as KVL. Now, these two laws are mostly used together in circuit analysis. So first, let's understand the Kirchhoff current law. Now, according to the Kirchhoff current law, the sum of the current entering a junction should be equal to the sum, and I'm using the symbol to represent sum, should be equal to the current leaving the junction. Now, what's a junction or a node? It's just a point where current split or come together. Like let's say this point. Let's say you have here as I1, you have here as I2, and you have here as I3. This is a junction because the current will split or come together at that point. Now, so according to KCL, at, at this junction, the current that is entering the junction, you can see the I1 is entering the junction. So I'll say I1 should be equal to, you see, I2 is leaving the junction and I3 is leaving the junction. Let's look at another situation where let's say I1 is like this and I2 is like this and I3 is like this. You realize that I1 is entering the junction, I1, I2 is also entering the junction, and only I3 is leaving, so it becomes like this. Let's look at another situation where I1 is like this, I2 is like this, and I3 is also like that. You can see that I1 is entering, I2 is entering, and I3 is also entering. So you come I1 plus I2 plus I3, and nothing is leaving, so it's equal to 0. So basically, this is the Kirchhoff current law. Let's look at a simple example to explain that. Let's say we have a node like this, where the current here is 2 amp, the current here is 3 amp. Let's say here is X, and here is 6 amps, right? So we can see that 2 amp is entering the junction, 3 is entering, but we have 6 leaving and X leaving. So we have this as 5 and this is 6. So X will be equal to 5 minus 6, and you have X as minus 1. Let's look at another example where let's say we have this is 2, this here as say I, and we have, let's say this, we have another current here as 4, we have another one that is say here as 3, and we have another one here as 7. It may be a lot, but one thing you should just look at, this is the junction, so we have to look at I is entering the junction, 2, this 2 is also entering the junction. We can see that 3 is also entering the junction, but then 4 and 7 are leaving the junction. They be at one side, so I will be plus, here is 5 and here is 11, so I will be equal to 11 minus 5, and that will be 6 amps. So basically, this is how we use the Kirchhoff current law. And in most situations in circuit analysis, you will have maybe a node looking like this, where you have here say I1 and here say I2, and you would want to know maybe the current that is here, right? And sometimes you don't want to put maybe I3. I will explain more on why you don't want to do that. But maybe if I want to know the one that is here, I can see that I1 is entering the node and I2 is leaving, and the one I want to find, let me call it X, is also leaving. So I can see that X will be I1 minus I2, and I want to come and put I1 minus I2 here. So basically, this is how the Kirchhoff current law is. Now let me introduce you to something we call the Kirchhoff voltage law. Now according to the Kirchhoff voltage law, if you take a loop, the sum of the voltage sources should be equal to the sum of the voltage drop. Or mostly I say that the sum of the voltage sources should be equal to the sum of the IRs. That's the current times resistance within a loop. Now, what's a loop? A loop is just a closed path that you can start from one point and come back to the other. Let's see, for instance, let's say I have a circuit that looks like this. Let's say I have a circuit that looks like this. So let's say this is 2, 3, 4, 5, 6. Here is a 10 volt, here is a 20 volt. Now a loop is just, let me call here, say A, B, C, D, E, F, G, H. So a loop is just a closed path. So let's say if I start from this point A and I go through to B, to F, to E, and come back to A, I can say this is a loop. So A, B, F, E, A is a loop. So basically, if we just can go around like this place is a loop, this place is a loop. One thing we can see is that this big one is also a loop. From here through to here is also a loop. We can say that from here through to here is also a loop. We can also say from here through to here is also a loop. So a loop is just a closed path. A loop is just a closed path. Now, one thing that you should know is that a loop can be taken in the clockwise direction or in the anti-clockwise direction. So any way that you take a loop, it also works. So depending on how you are taking the loop, Kirchhoff voltage law says the sum of the voltage sources should be equal to the sum of the voltage drops or the current times resistors. Now let's look at something here. Let's say I have a circuit that looks like this. Let me call this R1, R2, and R3. And let's say I know the current here as I1, I know the current here as I2, and I know the current here as I3. And see, here is V1, here is V2. And I want to apply the Kirchhoff voltage law. So according to the Kirchhoff voltage law, I have to take this loop. And from this loop, I have to put the voltage sources at one side and the current times resistance at one side. So now let's say I want to take this loop in the clockwise direction. So this is clockwise and this is anti-clockwise. So in going in the clockwise direction and in this loop, I can see this is the only voltage source. The voltage source is the one producing the current in the circuit, right? So this is the only voltage source. And I can see that this is a current times a resistor and this is a current times resistor. So according to the Kirchhoff voltage law, put all the voltage sources at one side and put all the current sources at one side. Now, in putting the voltages at one side, one thing that you have to always make sure is that anytime that you are leaving the positive terminal of a circuit, you always make the voltage source positive, right? So this time that I want to go in the clockwise direction, I'm leaving the positive terminal. So I'll say V1 is equal to, so you see that's the only voltage source within the circuit. So I put it at one side and it should be equal to, here is the current times resistor and it is I1 R1. And I'm saying I1 R1 because I'm going clockwise and I'm following the direction of this I1. So it's I1 R1 plus, then here also you can see that I'm going clockwise and I'm following the direction of I3. So it's going to be I3 R2. So basically this is how we consider a loop in Kirchhoff voltage law. Let me also consider this loop in a clockwise direction. Now you see, because I'm going clockwise and I'll be going against the positive direction of the voltage, I'm going to say minus V2. I want to put the voltage at one side, but I'm going clockwise and I realize that I'm going against the positive direction of the circuit. So I'll say minus V2 is equal to, now when I get here, you can see that I'm also going against the current source. So I'll say minus I3 times R2. Then here, I'm following the current direction. So I'll say I2 R3. So basically, this is the Kirchhoff voltage law. Now let me consider this bigger loop from this side to this side in the clockwise direction. I'm going clockwise like that. Now, in this bigger loop, you can see that there are two sources. So I have to make sure that the two sources, this and this, are put at one side. And this current times resistor and this current times resistor is also put at the other side. So let me leave the positive terminal here and go clockwise. So I can see that V1 is positive because I'm leaving the positive terminal. But I will go against the negative terminal here. So it's minus V2. Then it's equal to, then here I'm following the arrow direction. So I'll say I1, R1. And here I'm also following the arrow direction. So I'll say I2, R3. So basically, this is how we use the Kirchhoff voltage law. Lastly, let's look at a circuit like this. Let's say we have here as I1, here as I2, here as I3, and here as say I4, here as I5, I have here as I3. Now, according to the Kirchhoff voltage law, let's try to take various loops within this circuit. First, let's take this one. And one thing is that when you are using the Kirchhoff voltage, you can decide to go clockwise or anti-clockwise. So this particular loop, let me go clockwise. So here I'm leaving the positive terminal. So I'll say V1 is equal to, here is I1, R1. Then here too, I'm following the arrow. So I'm going to say I2, R2. Now let me take this particular loop and I'm also going in the clockwise direction. Now you can see that here, within this loop, I can't see any voltage source within this particular loop. So I'll say 0 is equal to, then here I'm following the I3 direction. So it's going to be I3, R3. Here I'm following I4 direction. It's going to be I4, R4. And here I'm going against the I2 direction. So I'll say minus I2, R2. Now let's look at this loop. I want to go in the anti-clockwise direction. You can decide which direction you want to go. And because I want to go in the anti-clockwise direction, I'm leaving the positive terminal. So I'll say positive V2. Then here I'm against the I5 direction because of the way I'm moving. So it will be minus I5, R5. And here I'm in the direction of the I4. So I'll say plus I4, R4. Now these ones look variables. So the circuit looks to have I1, R1 and all that. If these are values, the circuit becomes very simple. So basically, we've learned how to use the Kirchhoff current law and the Kirchhoff voltage law. In the next class, we are going to see how we can combine these two laws, the Kirchhoff current law and the Kirchhoff voltage law, to analyze circuits. Thank you.